Hey friends, this has definitely been a week of recording videos, and so thanks for watching all the videos. We're gonna move out of macromolecules and all this talk about atoms and things like that, and we're gonna go into cells. And cells is something you guys have covered before, and a lot of it is review, and it's not a lot of new things. And so we're gonna act like you know a lot of this already. And so if you don't, let me know, and we can backfill some information. But for the most part, you guys have covered cells a couple times in your science education at Calcasco or anywhere else. And so there's nothing's gonna be new. Now, one of the big things I do want to get out of cells is I want you guys to start picturing cells for what they are. You have almost 100 trillion cells inside your body. They're all unique. They're all doing a job. I think of them almost like as an individual person, and they're all interacting with the different cells around them, kind of like you interact with the people around you. And each one has a job, just like each one of you will have a job in our society, hopefully. And they're all interacting. And when we go through this, I want you to kind of recognize that a lot of this stuff is bizarre, one, but two, really, really, really cool. And we don't think of ourselves of these things, but this is a tour or an animated video of a human cell. It's going to be of I believe it's a white blood cell that is tumbling inside of a vessel. So I'm going to play the video. It does have a song. You might be able to hear it through my setup. I'll even turn up the volume for you. Okay. But I'm going to stop it a couple times and I'm going to talk through it. And I don't mean to be rude or anything or try to distract you. And I might pause a couple times, but I really want you to know what you're looking at in here. Okay. And sometimes I'll just let it play. All right, guys, here we go. Did I hit play? There we go. So here we got a white blood cell. And it's tumbling along here. And you can see as it's tumbling, it's using these protein lectins to kind of transport and kind of use as like Velcro as it's moving. This is a wider picture of it, okay? A wider picture of it. So it's outside the cell. We can see the p-selectin there, it connecting. So we're kind of stopped in motion right here. This is it kind of frozen in time for a split second. So these are the phospholipids that we just talked about in macromolecules in the lipid section. So these are the heads, these are the phosphates, and you're gonna be able to see the tails a little bit. And so these are polar. So if I want to make sure I don't connect to them, I'm going to need to be non-polar. You see, we'll have a lipid raft here made of lipids. We'll have things on top here that we're moving around. This is outside the cell, by the way. You can see these are little cholesterols pointing out. Little cholesterols, we talked about this is the glue of the cell. You can see the little tails right here, the phospholipids. These are the lipid parts. These are the phospho part there. Chemokine and proteoglycan, those are basically signals. They're sending a signal to each other right now. Again, this is still stuck in this motion. Like this is the guy rolling. So this is all happening within a split second. So we're entering the cell. So now we're looking up at the top of the cell membrane, inside of it. So this is inside, this is outside the cell. We got some proteins here that are sticking out. You kind of see how crazy proteins can get. We kind of saw that with the ribbon formation in the notes earlier this week. This is a spectrin tetramer that's kind of like a netting on the outside of the cell membrane, kind of used for transport and keeping things together. So I believe now we're going to go inside of the cell. So we're going to turn our focus here. We're going to flip. These are cytoskeletons, actin filaments. So that's microfilaments. We're going to call them cytoskeletons in our class. So you can kind of see they're everywhere inside the cell. Now they give structure, but they also allow things to move. So this is a dehydration synthesis of them connecting together. And they can connect together these different monomers here. Repeating structures. This is an enzyme coming over and breaking one down, so it's creating hydrolysis, allowing it to happen. We're going to do microtubules next. So this is, again, looking at a dehydration synthesis of it coming together. Again, this is going to be used for transport and structure, almost like roads. And that is it coming apart, unzipping, hydrolysis here, breaking apart. It's kind of crazy watching it break apart. This is a motor protein. It connects the organelles and helps move them. This is a vesicle here. Vesicles are used for storage. So you got these little motor proteins, almost like little robots that are carrying things around and moving things around. You can kind of see on the outside of the vesicle, they have these little protein keys. This allows things to connect to it and communicate with it, or for it to open up or close, whatever it needs to do. These little slug things in the distance, here and here, those are mitochondria. They're the powerhouse of the cell. I know everyone wanted me to say that. They're going to make energy for your cells. We're going to talk a lot about mitochondria. They're very, 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 very unique. So the centrosome kind of helps make microtubules and things like that. And then the central with inside of it. These are organelles that make up cells. So this is nuclear pores. This is RNA that's leaving. So this RNA was just made inside the nucleus, and it has a certain code to make a new protein. Okay, so this is the code to make a protein here. To make the actual code, we're going to use this little organelle called a ribosome, and it's going to make a protein by reading the code. So it's making the protein that the code is telling it to make. And disassembles the ribosome after being used. And then two proteins running into each other, forming a bigger protein. Again, same kind of ribosome connecting this lower part subunit, top subunit. Sometimes the ribosome will come to a certain spot in the cell and actually deliver the protein to a certain spot. This is the endoplasmic reticulum, or we're going to call them ERs. There's two different kinds. There's rough and smooth, and they're giving off little vesicles that are carrying proteins in them. Again, we have the moving protein carrying a vesicle itself. You're kind of getting an up close look of the outside of it here and what it's made up. These are different kinds of proteins connected together. So the Golgi apparatus, I like to call them like soggy pancakes. Its job is to basically be the mailroom. It's going to take in vesicles and it's going to tell them where to go and kind of give them a stamp and kind of give them some direction. We call them Golgi body or Golgi apparatus. They used to be called Golgi body, but now we've changed the name to apparatus. Again, same guy moving. It's like the journey of this one motor protein carrying this vesicle. He's trying to carry it to the outside of the cell, because what he does is he delivers the things that were in the vesicle. So now this is all the stuff that was in the vesicle being thrown out of the cell. And then we kind of reverse back to everything that we saw already. And so that's kind of what inside of a cell looks like. And you got to remember, that was a split instant. So time is a whole other conversation. And if you want me to go crazy about time, we can go crazy about time. But that was just a split second with inside of a cell. That's when the cell was actually rolling. So if we kind of go forward a little bit here, and we're watching the cell basically do this. And we're watching a split second where it's stuck. All that was happening where it was stuck like that. This leukocyte is going to go between two cells. And they can change shape and go where they need to go. Kind of cool. So I hope that's a cool intro to cells. We're going to be talking about them next week. I hope you guys enjoyed it. Good day.